good morning students. We are going to continue the last class. So here in the present class we are going to see about the other kind of directives which are going to be supported by the macro assemblers. One is a proc, another one is a NP, external, global, public, offset, PTR, ORG. Okay, now PTR is nothing but the pointer. We'll see that one by one, no problem. So here let us see what exactly the usage of the proc, and the NP. These two are looks like our segment and ENDs. What is the main intention of the segment and ENDs? They are showing the starting of the logical segment and the termination of the logical segment. They are showing the starting of the logical segment as well as the termination of the logical segment. So similar to that, here we are having the proc. Here we are having the proc and NDP to indicate where exactly your subroutines, means whatever the subprogram you are writing now, where exactly your subroutine is starting and where exactly your subroutine is terminating, in order to indicate that starting point and the termination point of your subroutine. So subroutines are called as a procedures. Subroutines are called as a procedures. In order to indicate the starting of the procedure and the termination of the procedure, we are having the we are using the these two assembler directives provided by the MASL. These two assembler directives provided by the MASL. If you want to know the syntax, how to make use of the proc and NP, then I'm just taking one example. So look, I'm assuming that the label assigned to my subroutine is a my proc. The label which is assigned to my procedure is a my proc, and I'm making use of my directive. Let us suppose it is a it is a proc. I'm simply using the directive proc. So if you are getting confused, then I'm going to make use of a separate color code, and it is going to be the PROC space. And here we are supposed to mention whether the subroutine is there in the present logical segment, means where exactly you are writing your program, whether it is there in the present segment or it is there in the some other segment. That should be explicitly informed to the assembler, so that it is going to be realized that whether your subroutine is existed within the present segment or it is there in the some other segment. It is there in the some other segment or it is there in the present segment. Okay, now. So we are supposed to cross check that one. Means we are supposed to explicitly inform that information to the assembler. We are supposed to explicitly inform that information to the assembler with the help of two words called as a two words called as a two words are there called as a near and far. If I'm using the near, then I'm mentioning that whatever the subroutine I'm going to write over here, that subroutine is existed in the same segment. If at all I'm using, instead of near, if I'm using the far, then I'm mentioning that whatever the subroutine I defined over here, that subroutine is not existed. That subroutine is not existed in the same segment. It is existed in the some other segment. It is existed in the some other segment. Okay. So my proc space proc followed by the far. Okay. So now in order to terminate this one, means let us suppose I have written some program. This is my as I said, this is a my proc, just like our my code, my data label what we have taken for a particular logical segment, and this particular my proc is also showing the label, means it is showing the starting address of our program. And proc is nothing but it is a directive provided by the MASM, and far is a keyword. And this particular keyword is indicating whether the procedure is there in the present segment or in the some other segment. Okay, now if we are having the near, then it is there in the present segment where exactly you are working, and if it is if we are using the keyword far, then it is showing the whatever the procedure we defined, that is there in the some other segment, not in the present segment. Okay, not in the present segment. Let us suppose I am writing one subprogram. In the subprogram, I am again performing the same addition operation. So I'm just continuing with the same example. So don't worry about it. As we move on, we are going to show that different types of programs. Don't worry about it. Program is nothing but just remembering the logic. That's it. Okay, now. So no need to by heart the program. So just remember the logic. So I'm just terminating my program. Okay, now I'm just done with the addition. Okay, now addition is over. Now we are supposed to return to the main program. So in order to return to the main program and in order to show the termination of my procedure, that is a subroutine subprogram, I'm just again using the same label name what I used as the starting one. So I'm just using the same label name. Okay, now so this label name is going to be, yeah, which one we used, my proc. I just use my proc space, and I'm using the another directive called as a endp, another directive called as a endp. So proc directive is indicating the starting of our subroutine, endp indicating the termination of our subroutine, endp is indicating the termination of the subroutine. So endp is nothing but end of procedure. So here we are having the segment, and the ends is nothing but the termination of your logical segment. End is indicating the termination of your entire program. Endp is indicating the termination of your procedure, which is nothing but the subroutine, which is nothing but the subroutine. Okay, now let's go to the extern. What exactly the usage of the extern is a question. Extern, public, and global. So here the extern, public, global, yeah, before going to this, I think you realize this concept, right? I'm just writing one subprogram, performing the addition, I'm terminating my subprogram. So starting is a proc and a termination is the endp. That's it. Okay, so let us go for the another kind of directives. Okay, another kind of directives, that is nothing but the extern, public, global. So what exactly the extern is a question. Sima, as I said, when we are defining when we are developing the application is divided into so many modules. The application is divided into so many modules. They are developed individually. Later on the linker is the one which is going to be linking all the modules and preparing one application. So here are somewhere we are supposed to share some variables. We are supposed to share some variables between the modules. We are supposed to share some variables. We are supposed to share some variables between the modules. We are supposed to share some variables between the modules. Okay, now. So in order to share some variables between the modules, okay, now. Let us suppose I'm having the one module. Okay, now. So I'm having the one module 1, and I'm having another kind of module which is nothing but the module 2, which is nothing but the, oh, I'm sorry. Okay, so let me take the downstairs. Yeah, module 2. Okay, now I'm having the module 1, module 2. Let us suppose there is a variable. Okay, now let us suppose there is a variable which is commonly used. I'm assuming the variable y, or if you want to give some valid name, then I'm going to use the price, or otherwise as we are taking the application, that is a college application, then I'll go with the roll number. Okay, now I'll go with the uh, yeah, r dot n. I'm simply writing the r dot no roll number. Okay, now so I would like to share the roll number between the modules as a common variable. Then what I'm supposed to do means, let us suppose initially it is declared in the module 1. The roll number variable is declared or defined in the module 1. Now I would like to make use of the same roll number variable in the module 2. Initially it is declared or defined in the module 1, and I'm going to make use of the same roll number variable in the module 2. I'm going to make use of the same roll number variable in the module 2. Okay, now. So here, when you are declaring one variable for the first time in the module 1, it should be declared as a public. Means you are supposed to declare your variable in the module 1 as a public. Means I'm going to make use of public. Let us suppose it is in the byte format, then public byte space byte colon, I'm just defining r dot no. Okay, now. So means here I'm mentioning me Sima, this format, this declaration is there in the module 1. This declaration is there in the module 1. I'm saying to the assembler that I would like to define one RNO variable, which is the roll number variable, whose size is a byte format, and declare that one as a public. Declare that one as a public. When we are declaring one variable as a public, when we are declaring one variable as a public in the module 1, when we are declaring one variable as a public in the module 1, then we are saying to the assembler that we are saying to the assembler that this variable is available in the defined module, means in the present module, as well as this variable is also available for the some other modules. If this variable is also available for some other modules. Let us suppose I would like to reuse of this variable in some other module where it is not defined. In the defined module, it should be declared as a public, and where exactly you would like to reuse of that particular variable in some other module. At that time, in the let us suppose I would like to make use of the same variable in the module 2. Then in the module 2, I need to declare this variable as a extern. I need to declare this variable as a extern, followed by again the size is a byte colon r and o. The size is a byte colon r and o. Okay, so means here when you are using the external keyword, using the external directive, you are informing to your assembler saying that the rno variable is not there in our module, in the present module. This rno variable is there in the some other module, and it is declared as a public, okay now. So means with the help of the extern, we are informing explicitly to the assembler whether the variables are declared in the present module or in the some other module. If you are using the extern, then obviously that variable, whatever the variable we declared using the directive extern, that is not there in the present module. It is there in the some other module. But whatever the variables you would like to make use of in some other modules, when you are defining those variables for the first time, those modules should be declared as a public. Okay, those modules should be declared as a public. And another case is a global. So what exactly the global means? No sir, I'm getting confused with the public and external. Then you can simply declare the variable as a global. Means all the variables are going to, whatever the variables which are declared as a global, they are available for all the modules. All the modules, and you can interchangeably use the global directive instead of the extern and the public. Okay now. So the next directive is means same thing. For the declaration of the global, you can make use of the same syntax. Okay. So the next concept is the offset. Okay. Now next directive is the offset. Okay. So let us go for the offset also. So here, what is the use of the offset is a question. Seema, here are somewhere we declared the variables. Means we have taken the data segment, and inside the data segment we declared some variables. In the last class we have seen the program. Okay, so I declared one data segment with the help of one data logical segment with the help of the my data label, right? So here I would like to know what is the address of that particular variable in that particular segment. What is the offset address of a particular variable in the data segment? So in the last class, what we have done, we declared the two variables now, three variables, value 1, value 2, and result. Let us suppose I would like to know the what is that offset address of result in the data segment. And I would like to read that value, that offset address, into one of the register. Then I'm going to write one syntax, one instruction. So means I'm just writing the move bx comma, I'm using the offset directive, followed by whatever the variables offset address you would like to know. You are supposed to write that variable name. So let us suppose we are interested in the result now. So I'm just writing the result. So when you are writing this statement, move px comma offset of result, then the microprocessor, that is the assembler, is going to be picks the what is that offset address of the result, which is declared in the my data segment. What is the address which is assigned for this particular result variable? That result variable offset address is going to be stored inside the bx. Means bx is holding the address of the result. In simple format, bx is holding the offset address of the result. Okay, so that is the main intention of the offset. Or otherwise, I can simply say that offset can also be, means if you want to explain in the different way, we can say that it is going to be calculates the displacement value of your variable in that particular segment. It is going to be calculates the displacement of a particular variable in that particular segment. Displacement value of a particular variable in the data segment, or whatever the segment where exactly you define your variable. Okay, now so that is going to be calculated and stored inside a 16-bit register, because the offset size is a 16-bit only. Offset address is a 16-bit only. That is going to be stored inside the 16-bit register. Okay, now so that is the offset. So now let's go to the PTR. So what exactly the PTR? PTR is nothing but it is a pointer. Now PTR is nothing but it is a pointer. So where exactly we will make use of the pointer is a question. So here let me take one simple example. I'll erase this one. Oops, I'm sorry. I'll erase this. Let me go to how we are going to make use of our PTR. What is the use of the PTR? So let me take one simple example. So here I'm simply taking the INC space BX. What is the meaning of this one, ma? What is the meaning of this? Let us suppose before this instruction, I'm assuming that the BX value was 3500H. The BX value was 3500H. Now, so means before using this instruction, I'm assuming that the BX content is a 3500H. 3500H. What is the use of the INC BX is a question. What is the use of the INC BX is a question. So this INC BX is nothing but it is incrementing the BX content by 1. It is incrementing the BX content by 1. Let me take the comment format. So I'm just writing the comment. Means how exactly this operation is going to be done. BX is equals to the BX plus 1. Means BX is incremented by 1 and the result is going to be stored inside the BX. Now the BX value is how much? 3501H. 3501H. This is a present value. Okay now. But let us suppose I would like to increment a value. Stored inside the 350H memory location using the indirect addressing mode of operation. Means now I am assuming that 3500H is a memory location. It is a memory location. So I am just taking one box, only one box to indicate one memory location. So I would like to increment. I am assuming that the value which is there in this box is a 05H. Okay, now the value which is there in this box is nothing but in the memory location 3500H, and the value is there in this particular 3500H memory location is a 05H. It is a 05. Okay, now I would like to increment this particular 05H content available in the 350 memory location using the indirect addressing mode of operation. So here I'm not considering this instruction. So it is a previous example how exactly the INC instruction is working. Okay. Now, so here for this explanation, BX is equals to the 3500H. For this explanation, again I am taking the BX content as a 3500H, and I am assuming that this content is referring the memory location which is a 3500H. It is referring the memory location which is the 3500H. Inside that particular memory location we are having the value 05H. I would like to increment this particular 05H by 1. Using the indirect addressing mode of operation. You may say that, sir, we can make use of the INC followed by square bracket BX. You may say that, sir, indirect addressing mode is nothing but putting the offset address inside the square brackets. Then if we are putting that one in the square bracket format, then it is easily incrementing the BX means the memory location by 1. But if you are doing like this, so here as per your analysis, increment space square bracket BX means you are thinking that BX content is indicating the 3500H, and that particular 3500H is used as a memory location. Whatever the value is there in that particular memory, it is going to be incremented by 1. Okay. So up to your knowledge, it is right, but actually this is wrong. Means when you are mentioning like this to the assembler get confused. Whether it need to increment the value, whether this particular BX is indicating the 8-bit value or the 16-bit value. Whether this particular BX memory location is used for indicating the 8-bit number or the 16-bit number. 8-bit number or the 16-bit number. Okay now. So as I told you that when you would like to represent the 16-bit number, you are supposed to give the starting address of your word. So starting address of your word means word is nothing but it is taking the two memory locations. One is the 3500H and another one is the 3501H. Another one is the 3501H. We are having the 3500H as well as the we are having the 3501H. So these two memory locations are used for holding the word information. Consecutive memory locations means continuous memory locations or side by side memory locations. So it is a continuous memory locations. So when we are using the two continuous memory location to hold the word, we are giving the starting address of the word. We are giving the starting address of the word. Not we are not giving the two memory location addresses to show the 16-bit number. Whether it is a 16-bit number or 8-bit number. If it is a 8-bit number, directly we are mentioning the offset address. If it is a 16-bit number, we are giving the starting address of the word. We are giving the starting address of the word. But if you are using this instruction, the confusion is whether the BX content, which is a 3500 na, in both cases, in the word case, in the byte case, we are using the 3500 only. Now the question comes that assembler get confused that whether it need to treat the BX content which is referring as the 8-bit number or the 16-bit number. There is a confusion. So to avoid that particular one, we are making use of the PTR. We are making use of the PTR. Okay now. So here means what we are going to do means we are going to make use of the INC. I'm just using this one. INC byte space PTR space square bracket BX. Square bracket BX. Here explicitly I am mentioning that increment the content which is in the byte format pointed by the BX content. Pointed by the BX content. What was the BX content? 3500H. So means 3500H is not representing the 16-bit number. It is representing the 8-bit number. It is representing the 8-bit number. Okay now. So because we are mentioning with the help of the byte word. We are mentioning with the help of the byte word. It is incrementing this byte specified by the BX content is how much? 3500H content. It is there in the 05. It is the 05. So soon after this instruction got executed, now the 05 memory location, this value means whatever the value is there in the 3500H, that is going to be incremented by 1. Now this value is going to be the 06H. Because we are explicitly mentioning that the pointer which is pointed by the BX is a byte, not the word. No sir, I would like to make use of this BX content as a word representation. Word representation means we require the two memory locations, but we are giving the starting address of the memory location to represent the 16-bit number. Okay now. So for that, again I am writing the instruction, means for the byte format I am writing the instruction. So sorry, for the word format I am writing the instruction INC. Same instruction is going to be used. Instead of byte, we are going to use the word space PTR, word space PTR space square bracket BX. Square bracket BX. Okay now. So here in this case we are saying explicitly to the assembler that increment the a word by 1. Increment a word by 1 which is pointed by the BX content. Which is pointed by the BX content. Now the BX address is taken as a 16-bit number. Now the BX content is taken as a address for the 16-bit number. Previously it is the address for the 8-bit number. Now it is the address for the 16-bit number. So that is indicated by which keyword, keyword word. With the help of the word we are mentioning that. Okay now, with the help of the byte we are mentioning that the BX is referring the 8-bit number. With the help of the word we are mentioning that the BX content is representing the 16-bit number. It is representing the 16-bit number. Okay now. So the next last one is the ORG. Last one is a ORG. Wait a minute. Last one is the ORG. ORG is nothing but the origin, which is showing the starting, means from where exactly your program is going to be stored. You are supposed to use the in order to indicate from where exactly your program is starting and from which memory location onwards you would like to store your program. So you would like to store your program in the using the MASM assembler. You are supposed to make use of the ORG, means wherever the MASM says ORG, syntax like this. Syntax like ORG space some number. I'm just taking the 000H 40H. So means I'm asking the macro assembler load macro assembler is nothing but the MASM assembler load my program, whatever the program which is written after the org command, after the org directive, load that one from the offset address which is nothing but the 4 zeros h, which is nothing but the 4 zeros h. So org is a directive which is indicating from which memory location onwards you would like to store your program. That information is given explicitly to the MASM assembler. That information is indicated explicitly to the MASM assembler. So here from the manufacturer to manufacturer, same directive can also be represented. Using the .org format, using the .org. So some directories are indicating only the org. Some assemblers are using only the org directive to indicate the starting of your program, from where exactly your program should be loaded, how you are interested. Okay, now you are mentioning like that. So some other assemblers, instead of the MASM is using the org. Instead of MASM, some other assemblers may use the .org. Okay, now don't get confused, because it is a one of the Viva question. It is a one of the Viva question. What is the difference? They may ask you like this. What is the difference between the org and .org? Simply say that both are functioning same, but from the assembler to assembler, the org usage is going to be changes. Okay, now. So this is all about your assembler directives in 80. In macro assembler, which is nothing but the MASM. Okay, now. So here the important thing about the assembler directives and programming development tools, what we have seen, you may get the short question. Definitely, it is one of the important short question. You may get any one of these directives. They may ask you to explain 3 or 4 directives, or they may ask you the programming development tools, like we have seen the editor, assembler, linker, locator, debugger, all those things. And they may ask you like that. Okay, so it is one of the important short question as per your exam point of view. I hope you realize the concept. If you are having any queries regarding this topic, so let me know that. Okay, so that's all for today's class. So we'll continue the next class with programs, or otherwise we'll go with the next topic.